Hello, everybody. Welcome. Today, we're going to continue discussing ecology here with one of the fundamental principles of ecology, and that's a discussion of climate. Right? Because eventually, we're going to lead to the point where we're talking about biomes. But first, we have to understand the difference between weather and climate and the effect that it can have on life. So let's start there, right? What is the difference between weather and climate? Weather is the day-to-day conditions that are present in Earth's atmosphere, while the climate are these long-term patterns of both temperature and precipitation over many, many years. Right? Climate is based on wind, clouds, precipitation, temperature. While weather has day-to-day fluctuations, climate is relatively stable in an area unless there's some kind of climate change. This is why if you ever hear politicians say, man, it's really cold outside today, we can sure use some of that global warming right now. That politician obviously doesn't know the difference between weather and climate, right? Weather fluctuates. Climate is this long-term pattern that there's lots of data for. So one of the main principles that climate is based off of is the absorption of solar energy and the greenhouse effect. So let's just talk about a greenhouse here, right? If you've ever been into a greenhouse, you know that it's noticeably warmer than the outside. That's because energy enters through the greenhouse in the form of light. Light is one form of energy. We're going to talk about another form in a second, right? So light energy enters the greenhouse. Some of it gets trapped, and a lot of that energy gets converted from light to heat. Then we have some of that energy passes back through the walls, whether that's from light or a little bit of heat radiating out. But in general, the inside becomes warmer than the outside because this light becomes trapped and turned into heat. Well, that same principle happens in Earth's atmosphere, right? So we have sunlight come into Earth's atmosphere. Some of it radiates back off, right? It's reflected back into the atmosphere, but some is absorbed and turned into heat. There's the light reflected. But some of that heat is absorbed and it's radiated by the greenhouse gases, and that heat is retained within Earth's atmosphere. That is the greenhouse effect. Generally, the greenhouse effect is a positive thing for our planet. Without the greenhouse effect, we would not have life on Earth. Earth would have extreme temperature swings between extremely hot and extremely cold. Basically, what the greenhouse effect does is it spreads the heat out over Earth and makes the whole planet habitable, right? Our atmosphere is responsible for giving us conditions that are beneficial to life. Think of other planets in nearby areas. The best example is Mars, right? Mars had signs of water. Water is one of the main components of life. The reason there's no evidence of sustained life on Mars, one of the main reasons is there's no real atmosphere on Mars to capture that heat. So this greenhouse effect, very important, right? Just understanding the basics. Light is absorbed, turned into heat. Some of it is reflected back out, but that heat is retained in the atmosphere through greenhouse gases, and we lose some out through space. Eventually, will lead to our discussion in a little bit, probably right after spring break, on human impact on greenhouse gases and their impact on climate change. But just understanding what the greenhouse effect is a good starting point here. All right, so that's one way that climate could be affected, right? That leads to a temperature. Let's talk about some other ways. Another determining factor of the climate of an area is the directionality where the sun comes in. The most direct regions where sun comes onto Earth are called the tropical regions. Those are where we see things like the tropical rainforest, or the deserts in the Sahara, right? All of those straddle the tropical regions because they're getting direct sunlight almost all year. Places that get less direct sunlight are called temperate regions. You live in a temperate region where in certain times of the year, the temperature is a little warmer because they're getting more direct sunlight. And in certain times of the year, it's a little colder because you're not getting as much direct sunlight. And then finally, the very extremes on the outsides are the polar regions. So we've got greenhouse effect, directionality of light. Let's then talk about winds. Wind is basically caused by a difference in temperature in the atmosphere of two different areas, right? So this actually goes to what we just talked about with like uneven heating of the earth, right? So if air in one area is really warm because it's getting constant sun, the sun is warming up the atmosphere, and another area isn't getting as much sun because it's just not as constant, the temperature is cooler. What happens is we have a situation where warm air rises. So right here, warm air is rising up in the atmosphere, and then cold air sinks. And so when warm air rises and cold air sinks, they start to form this little vortex. And throughout the world, there are multiple versions of these vortexes. You can see here, here, and here, where wind patterns are relatively constant, and wind affects temperature. Um, let's talk about ocean currents next. Ocean currents work pretty much the exact same way. Cold water sinks, warm water rises. There's lots of cold water by the poles because of the ice, a lot of warm water in the equator region. And so the cycling of cold and warm water in the same way that wind cycles causes ocean currents. Here's a very famous ocean current right here. This is the East Australian current, made famous by Finding Nemo. And then finally, let's just discuss regional climates. So regional climates are basically the difference in climate between two near areas. The best example I have for you is the difference between climate for Oakland versus Pleasanton. Um, what separates Oakland and Pleasanton is just a little mountain range. Um, if you've ever been to Oakland and spent time there, you know the temperature is generally cooler. It's a little windier. Um, the summers never get as hot. The winters stay a little bit cold, but there's not like extreme dips in temperature. Well, Pleasanton has super warm summers, really cold winters, and there's more like extreme dips in temperature. Um, the difference between those two areas, even though they're only separated by 10 miles, um, is explained by this diagram. Oakland is closer to the ocean. Um, being closer to the ocean means that the air is cooler and there's more moisture in it. Well, as that air starts to come off the ocean and go over the mountain range, um, the air rises over it and cools down. And as it cools down, it releases moisture in that area. And then it makes its way over the mountain range. Well, as it makes its way over the range here, the air starts to descend, it becomes warmer and drier, and it decreases moisture. So this side is like Oakland, while this side is like Pleasanton. More moist on this side, generally cooler. On this side, it is warmer, a little bit drier. That's regional climate. Even though California might have a certain climate because of where it is in the world, if you think of latitude, how much sun it gets constantly, you can have these difference in climates because of things like how close you are to the ocean. Is there a mountain range nearby? Those things can lead to a difference in climate. Um, and so all of those things combined, right? Wind, cloud, precipitation, temperature, they all determine climate. Um, and a key thing to understand here is that there can be climate change without humans. Again, we will discuss at length how humans have caused climate change. Um, and you will leave our ecology unit understanding that pretty well. But it's also key to know that climate has changed on its own before with these non-human causes. Right? Volcanic activity has been known to increase the amount of carbon dioxide in the air, which is a greenhouse gas, which can change the climate. Mountain building, right? If you build a mountain in a certain area, it's going to change the regional climate. The distribution of continents and where the oceans are and how close the land masses are to each other, that can change the climate. Meteorite impact, Earth's spin, tilt, and how close it is, where it is in its orbit, and solar radiation. Those are all impacts or ways that can impact climate that are not human based. And so that's what I want you to get from these notes, right? So understand the difference between weather and climate. What are the factors that influence climate, and how has climate changed in the past without human influence? Um, so, thank you for watching.